Now we're going to compare volume after a change in the original shape. Okay, so we are going to compare. So how does it compare when you have a shape and then maybe you cut the height in half, but it's the same radius? How do the volumes compare? How do the volumes compare if you take this and you double the radius to keep the same height? So that's what we're going to do. We're going to look at increasing different components of your figure. All right, so draw this little figure. I'll make it a little larger. There you go. Draw the figure. And everyone should already have a calculator. So I want you to find the volume of that cylinder. And if you don't remember, we have the formula of V equals pi r squared h. This 6 is what? Radius. So what did we get for our volume? 339.12 inches cubed. So 339.12 inches cubed. Okay, now we're going to double the height. So instead of the height being 3, I want you to substitute in the height being what? 6. So do the same thing, substitute the height being 6. See what happens to the volume. Hey, Jake, what you got? Jake? Volume? Okay, so 0.24 inches cubed, so 678.24. So how does it compare? So you want to do 678.24 divided by 339.12. So the new volume divided by the old volume. How does it compare? Kylie? 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 It's doubled. So this is 2 times, right? If you divide it, it equals 2. So it's twice as big. So when you double that height, it's going to be twice as much volume inside. So if we're putting soda in and the can is double, then in height, you know you're going to get twice as much soda inside. Now let's look at something else. We're going to take that same cylinder, so that 339.12, that was the original one, right? The original volume. So that's the original volume. Now I want you to double the radius. Double the radius. So your new radius is going to be what? 12. Okay, once you double the radius, I want you to find the volume. Keep the same height. So, Anthony, what did you get for your volume? Okay, that is correct. So, I want you to compare. So, if you have this new volume divided by your old volume, and what did you get? Ethan? 4 times. Right? 4 times bigger. So, alright, so I want to know why, if we double the height, it's only twice as big. But if we double the radius, it's 4 times as big. Think about it. Talk it over with your shoulder partner. Natalie, what do you think? Why is it 4 times bigger? When I double the height, it's only twice as big, but as soon as I double the radius, 4 times as big. Science. All right. Jaden? Sean? All right. Brent?
Because
oh, Zoe? Ethan? Wait, guys, what? No, that's kind of what Zoe was saying. Anthony? Yeah, when you square the radius, when you're calculating, you square the radius, right? So, 2 squared, when I multiply it, is 4. All right. Okay, so what would have a greater effect on the volume of a cone? Doubling the radius or doubling the height? So think about your cone and the formula that you use. Discuss it with your shoulder partner. Anthony? Include Natalia. Anthony? Okay, so what do you think? You said doubling the radius. Why? You just took one and said, I'm going to guess this. Adrian? The height? Bye. So, if you poured this volume of water into the cylinder from this hemisphere, did you get a third, a half, or 2/3? What do you think? What do you think, Brent? 1/3? So, 2093 divided by 3140, about. What's it look like about? What do you think? What do you think? Sophia, what do you think? You think it's about 1/3, 2/3? Brent said 1/3. What do you think this ratio is? Well, divide it. Divide it. What do you get? What do you get? Come on. This is about 2,000. This is about 3,000. What do you have? Batteries? 2/3. It's about 2/3. About 2/3. All right. That one was a difficult one. I had to give you the height. So this one, think about the video you saw. Think about that video you saw. Okay, so don't blurt anything out. The machine uses a funnel shape of a cone to fill soda cans in an assembly line. The funnel has a height of 10 and a diameter of 8. How many times would the machine need to be filled? Will the machine need to fill a cone to fill a can of the same dimension? So, here's the funnel, right? You can. Here is the cylinder, the soda. So, how many times will we have to fill this to make sure that there's enough soda in the can to fill it? So think about that video. This one you shouldn't even really have to calculate. If you think about the video yesterday. Okay. All right. Let's see. When I called on Bryce, what do you think? Why is it 3? Thank you. What's that?
Took 3 cones to fill a cylinder.
You sounded like the guy on the video. So, it took 3 cones to fill a cylinder. Well, it actually, cones. Come on, little pen. 3 cones for 1 cylinder, right? Or 1 cylinder took 3 cones. All right, so it would take 3 cones. That is correct. All right. Oh, look at that.